Welcome to the House That STEM Built, a regular series where we will explore the science, technology, engineering, and math that goes into the design and construction of this family home. This is the House That STEM Built.
Today, we are going to focus on trigonometric ratios. Trigonometry is the branch of mathematics that describes the relationship between angles and the lengths of triangles. Trigonometry has lots of real-life applications in engineering, manufacturing, construction, architecture, and even music production. Trigonometry is often utilized in the safety and stability of construction projects and can be seen throughout the construction of the house that STEM built. Today, we'll be looking at how to use trigonometric ratios and their applications when it comes to designing and constructing roofs, stairs, and more.
We will cover the Grade 10 Geometry, Measurement, and Finance Specific Curriculum Outcome G3, demonstrate an understanding of primary trigonometric ratios.
When solving for the length or angles of a right-angled triangle, we can use trigonometric ratios. Before introducing the trigonometric ratios, we will have to look at labeling the sides of a right-angled triangle. First, we need to identify our angle of interest, which is represented by the Greek letter theta. This is the angle we either know or want to find besides the 90-degree angle. Next, we will identify the hypotenuse. The hypotenuse is always directly across from the 90-degree angle. Next, we will identify the opposite side. The opposite side is always directly across from our angle of interest. Our last side is the adjacent side. This is the side next to the angle of interest. There are three trigonometric ratios: sine, cosine, and tangent. When calculating the sine of an angle, we will divide the length of the opposite side by the length of the hypotenuse. When calculating the cosine of an angle, we will divide the length of the adjacent side by the length of the hypotenuse. When calculating the tangent of an angle, we will divide the length of the opposite side by the length of the adjacent side. When designing the layout of a house, the architect needs to decide how they want the house to look overall. The dimensions of the house will affect the angle or pitch for the roof and in turn, the materials that can be used. Trigonometric ratios can help determine the pitch of the roof and provide valuable information on what material should be used. Let's take a look at this in practice. When looking at the rafters of a roof, we can see that there is no 90 degrees. However, if we draw a line from the top vertex of the roof, we can create a 90-degree angle with the bottom support, resulting in a right-angled triangle on either side. If the height of the roof was 96 inches and half the length of the support was also 96 inches, we would be able to determine the angle of the rafter. First, we will start by labeling the sides of our triangle with known values. The height of the rafter is directly opposite the angle of interest, so it is the opposite side. Since we have both the length of the opposite and adjacent sides of the right-angle triangle, we can use the tangent ratio to solve for the angle of the roof. First, we set up our equation. Using tangent ratios to solve for the angle, we will use the equation. Tangent of an angle is equal to the length of the opposite side divided by the length of the adjacent side. If we look at our example, the length of the opposite side is 96 inches. Therefore, we will replace the numerator with 96. Next, we will replace the denominator with 96 because that is the length of the adjacent side. The first step to solving this equation is dividing 96 by 96. When you do this, you should get 1. At this point, you should have an equation that looks like tan of an angle is equal to 1. In order to solve for the angle, you will have to take the inverse tangent of 1. To do this on your calculator, you'll need to press the second function button followed by the tan button and then input the numerical value of 1. When you press the equal sign, you should get the value of the angle you solved for. In this case, our angle is 45 degrees. With this information, we now know that asphalt shingles would be suitable material for this roof, and it is an appropriate slope for repelling rain and snow. Another area of construction that uses trigonometric ratios is building stairs. Building codes state residential stairs should have a pitch between 30 and 35 degrees. If you know the pitch and height of a staircase, you can determine the horizontal length of the entire staircase. This horizontal length is important to know when working in small areas to ensure there is enough space in the entire room to fit an entire assembly. Let's look at an example. If you know that a set of stairs has to be 107 inches tall and you want the pitch to be 34 degrees, you could calculate the horizontal length of the stairs using trigonometric ratios. First, we will start by labeling the parts of the triangle. The angle the stairs make with the floor would be our angle of interest. The height of the staircase is directly across from the angle of interest. This means that is our opposite side. The final side we need to label is the length of the entire staircase. This side is next to the angle of interest and is not the hypotenuse, which means it is our adjacent side. Knowing that we have our angle of interest and opposite side and we want to solve for the adjacent side, we can use the tangent ratio to solve this problem. First, we need to rearrange our formula because we are solving for the adjacent side. Next, we need to substitute our known values into the equation. Our angle is 34 degrees, so we replace theta with this value. The opposite side has a length of 107 inches, so this will be placed in the numerator. Then we will replace adjacent with x. The final step is to divide 107 by tan of 34. We now know that the length of a staircase is 160 inches. Stairs and roofs can sometimes be difficult concepts when building a home, but utilizing math can simplify this process. What other situations might be made easier by using trigonometric ratios?